All right, this is problem number 27. Again, it's Bayes' theorem, but it's a much more challenging Bayes' theorem problem because our conditional statement is a binomial distribution. So we're told that we've got a flu vaccine coming from different companies, and company X delivers 1/5 or 20% of the vaccine at a rate of 10% effective. The remainder of the vaccines come from other companies, and they are at a 2% defective rate. We've got this conditional statement here, so we do a sampling, and we, in the middle of that sampling process, what we discover is that after choosing 30, one was defective, and we want to know the probability that we sampled company X and not one of the other companies. So let's go ahead and do visualize our sample space here. And we'll mark off 20% for company X, which means 80% for all the other companies, and is a 10% defective rate from company X, but only a 2% defective rate for the other companies. And then we do our sampling. So we're in one of two situations. Either we drew 29 from company X and they were okay, and then one of them was not okay, so 30 total with one defective. Or we were choosing from the other companies and we grabbed 29 and that were fine and one that was defective. So let's convert that into a fraction. We're being asked the probability that the sample we took came from company X, not from one of the other companies. So this is going to be our numerator. 20% of the time, we're going to be choosing company X, and our sample would come out like this. 30 choose 1 with 10% defective raised to the first power times 90% fine raised to the 29th power. That's your binomial distribution right there. And then that value will reappear in the denominator. 20% of the time, 30 choose 1, 10% to the 1, and 90% to the 29. But it could be that we are in this situation here, where one of the other companies was selected, and that's where our sample came from. So 80% of the time, that's what's going to happen, times 30 choose 1. And this time, if our defective samples come at a 2% rate, we'll do times 0.02 to the 1, and then 98% of the time, the other 29 samples will be just fine. So one thing you can note is this 30 choose 1 term is going to cancel out. And then if you churn all of that through the calculator, you could 0.096 or thereabouts. And the closest answer we have to that is A for 10%. So more challenging than some of the previous Bayes' theorem problems. This is certainly the sort of problem that if I encountered on the exam, and after 5 minutes I felt like I should be able to get it, but I still wasn't where I needed to be, I would mark it, move on, and hope I had time at the end.